not that difficult. The PhD student who's doing this worked on identifying differences between laser scans in her master's work and has some good solutions. There are out there many algorithms for that. And then we hope to identify the changes and through relationship to the bin model before to create new bin entities. Now part of the problem here is that those entities don't exist right now in BIM tools. There is no such thing in Revit as a broken beam or a cracked slab or a cracked wall or something like that. So part of the challenge right to begin with is to think about, apart from the identification, pattern matching, is to create those new entities, objects in the software. So we've begun by taking a BIM model of a beam, taking a beam, cracking it and breaking it. We have the benefit of being a School of Structural Engineering in the laboratory. They're doing structural experiments alongside us, and we have these things available. And begin scanning it, and then begin using these as the basis for the work. The same thing you can see here in a wall, and you can see here, without me pointing out to you, where the cracks in the masonry are. These models have been through earthquakes in the sense that the earthquake research that is done by my colleagues in the laboratory simulates real earthquakes. So the type of damage is similar. I can't report to you yet any firm results because we're only 6 months, 9 months into this work. But I can tell you what the problems are, and what the challenges are. They have to do with registration between the BIM model and the scan, between the two scans. We need to recreate a library of entities. We believe that we can use the RGB, the color data from the laser scanners to link into material identifications from the BIM model before. We need to do the change detection, and then even after that we have to do the compiled models. So there are a series of principal problems here. But the reason I'm showing this to you is just to give you a sense of the kind of things that we can think about doing with BIM modeling and the ideas that sit behind it and the technology, if we just think ahead. Chuck spoke this morning about different uses of models. I guess this is one you can add to the list. And probably many, many others. Let's move on to virtual reality. And here we're doing research for the Ministry of Labour concerning construction safety. And as was mentioned earlier, construction, apart from perhaps mining and some other esoteric industries, is the biggest and most dangerous industry of all. There are some figures there from different countries. In Israel, at least more than 50% of the people who are killed while at work are killed during construction. Many of them by falls, but also by being crushed, by being struck by objects, by being run over by construction equipment, and quite a wide variety of things. We did some previous work in this area, some earlier work, where we tried to use, let's say, a technological approach. And the technological approach involved taking a model of the building, taking the schedule of the operations that were due to be done, and taking a very large database that summed up the probability of teams losing control of whatever they were doing. And we then tried to see if we could figure out from the schedule if a particular team were up on a scaffold and they might drop a hammer or drop a stone or something, and there might be a worker down below doing some piping work, whether that constituted a danger and how dangerous it would be. Because of course, for an accident to happen, you have to have a loss of control hazard and somebody exposed to that hazard. Of course, you can drop something if there's no one there, no one is hurt. And can we run the first video? And so in running this, the way it worked was that you could take any model, you could link it to the schedule, and the database was set, and then the system would run. You could set different parameters for how you would want the display. I guess that's one of the most important part. But the system would then run through time in a 4D CAD sort of way, and it would highlight by colors where the most dangerous locations were over time. And the idea we called lean safety, because the idea was that if we found that there were areas of extreme danger, peaks of danger level, then we could reschedule. In particular, if there were two teams working in parallel in the same space or in one space that endanger another space, we could reschedule one of the teams or move them to a different location for that time of overlap. And so again, it's just a quick way to show the way that models can be used to run through. Now, the reason I showed you that is because we found that the technological approach was very limited. That in fact, there's a huge body of knowledge about construction safety and occupational safety in general. And one of the key lessons we learned was that we need to account for human error and think about how we can deal with the training of people, and not only the training, but especially their perception of a danger. When you go across the streets, you realize, of course, that you might be run over by a truck or a bus, but you probably don't have a good sense of how dangerous that is, or what exactly is the probability that you're going to be injured. And we found, and we suspected, that construction workers similarly have very little sense of how dangerous it really is to do something, work at height, work on a scaffold. What really is the chance that I'll fall and break my neck? Most construction workers have never experienced an accident, and in fact most of them never even seen an accident. So how would they know? Well, one way is through safety training. We expect that all construction workers and supervisors have some form of training. And so our second question was, how does that training work? Is it effective? And so if we can deal with hazard recognition or risk perception, maybe we can begin to help people understand the risks better than if they simply get classroom training. So our goal here was to say, can we use virtual reality, building models like virtual reality, to create a virtual site and then expose people to dangers that normally on a real site they couldn't do for ethical reasons, and see whether they identify the dangers, how aware they are, how they perceive what's happening. And so we're doing this. We have parallel projects going at the University of Reading and at the Technion, which you can see there. The method is that we have, for the first experiment, is that we have a virtual test where we use a cave. A cave is a computer-automated virtual environment. And the subject, the person, wears 3D goggles. You walk into the cave. By virtue of using the active goggles, you see 3D, and you're surrounded on all sides by the virtual world that you are in. And that's our tool. The experimental design says, let's take two groups, each group of 30 people. We have in each group 10 students who have no safety training, 10 construction supervisors who have some training, they have a lot of experience, and we take 10 safety managers who we assume have both a lot of experience but also a lot of training. And each of those groups of 10 first, well, two groups of 30 divided into 10s. The first group, we give them photographs like this. And we say, okay, what's dangerous here? If you were on that site, what could happen to you? What are the hazards? And we show them the photographs, and we ask them to identify the hazards. We then, like here for example, what's dangerous there? We then show them the same photographs again, but this time round, we number for them, and we mark for them on the photographs what the dangers are, like this, or like this, or like this. And then we ask them to please rate each of those dangers. There are 65. We ask them to rate them on a scale of 1 to 5 for how dangerous they are. And then we ask them, when they're done, we ask them again to go through the whole list once again, and this time to tell us, for each one, what's the probability that there will be an accident? And if there is one, what would the severity be? How badly would you be injured? On a scale of 1 scratch to 5 being killed. And the second group, the next 30, we do the same thing, but this time we do it in the cave. And we ask them to walk through a building. They start off on the ground, so they see the outside. We take them inside. They see avatars in the building doing things. They see construction equipment moving around. The equipment is bulldozers moving, trucks.